Hello everyone and welcome to Jam Academy. We have a very beautiful problem here to solve. A uniform chain, keep in mind that the chain is uniform. We're going to come back to that. A uniform chain of mass capital M and length capital L is hanging partially over the edge of a table. It's just about to sleep. Suppose that the coefficient of static friction between the chain and the table is 0.5. We have been asked to determine the maximum length of the chain that can hang down without slipping on the table. This is a very beautiful problem. So let's assume that the length of the chain that can actually hang down without slipping is X max, which is XM, and the total length of the chain is L. That means that the length of the chain left will be L minus XM from here right to here. Now we have demarcated the various lengths. The next thing that I would like for us to talk about will be the forces acting on the chain. Now on this side of the chain, we know that the chain is uniform, so the force will act at its center of gravity, which will be at the center. So the force acting downward is the weight of the chain. I'm going to call this mxg. Now, on the portion of the chain lying on the table is about to slip to the right, which means that the force acting to the right is the weight of the portion of the chain hanging over the edge of the chain, which is pulling the chain to the right. Now, if the chain is not slipping, it means that there is an opposing force. The static friction is acting to the left. So we have here static friction is acting to the left. I'm going to call this F of S, but keep in mind that the weight of this portion, I'm going to call this M prime G, and there is a normal force acting upward. I'm going to call this N. So this is quite beautiful. So the very first thing that you need to take note is that the chain is uniform. What does that mean if the chain is uniform? A uniform chain has a constant uniform linear density. In other words, the linear density of the chain lambda is constant. This is going to be equal to capital M divided by L. And this is going to be equal to, pay attention now, M X divided by X, which implies that the mass of the chain hanging is equal to capital M divided by L multiplied by X. So this is the mass of the hanging portion. Hence, the weight of the hanging portion, Wx, is equal to mxg, which will be equal to capital Mg over L multiplied by X. So this right here, my friends, is the weight of the hanging portion. The weight of the hanging portion. It's important you keep this in mind. Now, similarly, let's move on to the part of the chain lying on the table. It is temporarily at rest, which means that all the forces acting on that part of the chain balances each other. So if that is the case, we know that the sum of forces in the y direction is equal to 0, which implies that m primes of g is equal to n, which implies, Remember that M prime is the mass of the chain lying on the table. So this will be equal to M prime. Keep in mind that, let me use a different color, that capital M over L is equal to M prime divided by L minus X, which means that M prime is equal to capital M over L bracket L minus X. It's important you keep that in mind. So this is the mass of the chain on the table. Hence, we can therefore conclude that the normal force acting on the table, the normal force N, will be equal to capital Mg over L bracket L minus X. Now, by definition, the static friction, F of S, is equal to mu multiplied by N, the maximum static friction. Remember, the chain is just about to slip, which means that the static friction acting at that moment is maximum. So this will be equal to mu capital Mg over L bracket L minus X. But what is mu? Mu is 0.5. So this is just going to be equal to capital Mg divided by 2L bracket L minus X. Now here's the deal. On the portion of the chain hanging on the table, the force acting to the right is the weight of the hanging portion of the chain. That means that that implies that the sum of forces along the x direction is equal to 0, which means that F of S max will be equal to Wx. In other words, capital Mg bracket L minus X over L will be equal to capital Mg over L multiplied by X. Notice something. This is common on both sides of the expression. I'm going to put a 2 here. Let me use a different color to distinguish this. I'm going to put a 2 here, and which is this 2. Don't forget, sorry, on the other side, this is 1/2, which is that 2. That means that this takes care of this. In other words, we have we have L minus X equal to 2x, which implies that L is equal to 3x, and the portion of the hanging chain XM will be equal to 1/3 L. Will be equal to 1/3 L. So all things being equal, the maximum length of the chain that can hang over the table without the entire chain slipping across the table is just 1/3 of the length of the chain. This is a very beautiful problem, and I've actually given this problem a couple of times in my midterm examinations. So my recommendation for you is that review this problem, and if you do not understand the procedure, I will recommend that you participate in the discussion forum right below this video. Thank you and have a wonderful day. Bye-bye.